Okay, Algebra 2 fans, our topic for today is we're going to start a new unit. It's multiplying and dividing rational expressions. Before we start, let me tell you our Algebra 2, well, not our Algebra 2, but our joke of the day. Why don't they play poker in the jungle? And the answer is, there's too many cheetahs. Okay, so here we go. Recall multiplying fractions. When you multiply, if you're multiplying a fraction, you multiply the numerators together and the denominators together. So what we can get here, 3 times 10 is 30, and then 5 times 9 is 45. Now from there, we're going to simplify that, we're going to reduce. You can divide each of these by 15. You want to pick the biggest factor. You know, you could go by 5 and then you could go by 3 as well, but we are going to get 2/3. That's the simplified, reduced answer. Now there's another way you could have done this though without having to multiply across like this. Before you multiply, you can do some division, all right, or what we would call as canceling. As long as everything is multiplication, if I have a number in the top and a number in the bottom of the fraction, I can reduce those right away. So for example, 3 over 9 reduces to 1 over 3. So I'm going to reduce that at the beginning. And then 10 over 5 is 2 over 1. Now what this does is it makes my number smaller so that my last step, when I do multiply, 1 times 2 is 2, 1 times 3 is 3. There's my answer. It's already reduced. So this saves me some time. Another example here, 1/2 times 2/3 times 3/4 all the way to 7/8. Well, you'll see I could do 2 divided by 2. There's a 2 in the numerator, a 2 in the denominator, so I'm going to divide that. That's just 1. 3 divided by 3 is 1. The 4s, the 5s, the 6s, the 7s. And out of this whole mess, all you get is 1 on the top. And in the bottom, this is 8 times all these 1s, which is 8. There's your answer right there. Okay, so if you can reduce ahead of time, that's what you want to do first. So let's look at some examples here where we actually have variable expressions. So directions, simplify the following expressions. 7x squared divided by 3 times 9 divided by 14x. Before we multiply across, let's go ahead and simplify. 7 and 14, that reduces to 1/2. X squared divided by x, we subtract the exponents and it just becomes x to the first. Okay, so that's x to the 1. 9 divided by 3 is 3. So what we have here on top, 1 times x times 3. So that's 3x over, and in the bottom we just have 1 times 2, which is 2. That's the solution. That's as far as you can take it. So we're going to cancel factors, cancel common factors here. Okay, number 2. When you multiply this and then you do times 2x, think of that as 2x over 1. So the 2x is part of our numerator here. All right, let's see. We can do 3 and 18. That's just 1 and 6. 1 over 6. X to the first divided by x to the third. We're going to end up with x to the second in the bottom. 3 minus 1 is 2, but the x cubed is in the bottom of the fraction in the denominator, so x squared is in the denominator. 14 divided by 4. Each of those is divisible by 2. That's 7 over 2. I can now do 2 is in the top and 2 is in the bottom. 2 divided by 2 is 1. And then we have x divided by x squared. Well, that's x to the first divided by x to the second. If I subtract, if I do 2 minus 1, I get x to the 1. But that's going to stay in the denominator. So out of all of this, we have 1 times 7 times 1, which is 7. And then we have 1 times 6 times x times 1, which is just 6x. And that's it. That's as far as you can go. All right, how about number 3, where we actually have some parentheses here? Now notice, this is a factor times a factor times a factor. And same thing in the bottom. So even though you see plus signs and subtraction signs, we're dealing with multiplication of factors. So if we're doing that, we're allowed to cancel factors. For example, a plus 5 divided by a plus 5 is just 1. That's a plus 5 divided by itself, so it gives you 1. A plus 2 divided by itself is 1. Now, a minus 3 and a plus 3 are not the same factor. They're different. So I can't cancel those. I'm just going to write a minus 3 over a plus 3. That's as far as we can take it. You might be tempted to say, ooh, a divided by a is 1, but now you're canceling just individual terms. You can't do that unless everything is being multiplied. And it's not. This is a minus 3. It's not times 3. Okay, so that's as far as you can go. That's done. Now, number 4, this is 1d minus 7. And this is positive 7 minus 1d. What's happening here, I could take the bottom of this, the denominator, I could factor out a negative 1. And what would happen, this would become a negative 7, and this would become a positive d. If I write it like that, I could distribute, and there's my 7, and there's my minus d. Okay, so all I did was factor out a negative 1. Now, d minus 7 and negative 7 plus d, these are the same factors, so I can cross those out. But what does it leave me with? I have 1 over negative 1, so the answer is negative 1. If you have opposites, okay, positive d minus 7, positive 7 minus d, if you have opposites, they reduce to negative 1. It's kind of like saying 5 divided by negative 5 is negative 1. Those are opposites. Okay? So there's our answer. Number 5. Now these are not opposites. Yes, this is negative 7 and this is positive 7, but the c's are not opposites as well. So that's it. You can't do anything with that. That's your solution. It's already simplified. So notice the difference between number 4 and number 5. If this had been c minus 7 over negative c plus 7, that would be negative 1, because now they're both opposites, both terms. Okay, so now number 6. Now we're getting into a little bit more complicated problems. There's more stuff to do. The idea is that, I'm going to come back to number 5. You can only cancel factors. You can only cancel factors, not terms. You can only cancel factors, not terms. C and C, those are terms. I can't cancel those. I can only cancel the factors. Okay, so for number 6, well, I need to factor the top. I'm going to take the numerator and factor that. Now what I'm thinking here is two numbers that multiply to negative 24 that add up to positive 2. Multiply to the constant and add up to the middle term. And my winner is going to be positive 6, negative 4. 6 times negative 4 is negative 24. 6 plus negative 4 is 2. So I'm going to rewrite the numerator. b plus 6 times b minus 4. I'm going to rewrite the denominator. I didn't do anything to it, so I'm just going to copy it. Okay, what can we cancel? Notice that you have b minus 4 divided by b minus 4. That's 1, because you're dividing by itself. So what that leaves us, we get b plus 6 over b minus 6. That's as far as you can take it. Okay, that's all you can do right there. All right, number 7. Before you start canceling, what you want to do is you want to factor anything that you can factor. All right, so for number 7, 45x squared over x minus 9, that's already good. And I'm just going to copy that down. 45x squared over x minus 9 times. Now I'm going to factor the numerator x squared minus 5x minus 36. So what I'm thinking, two numbers that multiply to negative 36 add up to negative 5. And the winner is going to be negative 9, positive 4. Negative times positive is negative. Negative 9 plus 4 is negative 5. So this is going to be x minus 9 times x plus 4 over. Now in the denominator, we can factor out the greatest common factor, the GCF. 3x squared goes into both of these. So 3x squared, and if I divide out a 3x squared here, I'm left with x to the first, and then this would be plus 4. X squared divided by x squared is just 1, so that's just a 4. 12 divided by 3 is 4. Okay, so now think of this as one big numerator and one big denominator. So we've got factors here, so let's go ahead and start canceling. X minus 9 divided by x minus 9 is 1. X plus 4 divided by x plus 4 is 1. 45 divided by 3 is 15 over 1. X squared divided by x squared is 1. So out of all of this, all you have up top is 15. In the denominator, you just have 1, so the answer is 15. All right, and then last but not least, number 8. We've got a ton of stuff going on here, so we're going to factor this a piece at a time. X squared plus 4x plus 3 is x plus 3 times x plus 1 over 2x squared minus x minus 10. Well, on the side here, 2x squared minus x minus 10, I'm going to slide and divide. I'm going to slide the 2 down, so multiply by 2. X squared minus x minus 20. Two numbers that multiply to negative 20 that add up to negative 1. X minus 5, x plus 4. Now I have to divide. If I slide it, I have to turn around and divide it. So I'm going to divide by 2. Whatever I multiplied by, I divide by. Now negative 5 halves is reduced. I take the denominator, I bring it in front. So I get 2x minus 5 times, I reduce this, x plus 2. All right, so over here that's 2x minus 5 times x plus 2. There's the first fraction. Second fraction, I can factor out a GCF, 2x squared from both of those, which leaves me with 1 plus 2x. Okay, it's like when I factor out a GCF, it's like I'm dividing. If I divide out 2x squared from this, it's 1. If I divide out 2x squared, I get 2x. In the bottom here, we can factor out an x. So that would leave us with x to the 1 plus 3 times, all right, last fraction, the x is good in the denominator and in the numerator, and the denominator would be x plus 2 times x plus 1. So we've done all the work. Now you get to do the fun part, which is the canceling. So let's see, we've got x plus 3 divided by itself is 1. X plus 1 divided by itself. We've got, let's see, is there anything else here? X divided by x. We have that. All right, what else? 2x squared? No. We have x plus 2 twice, but they're both in the denominator, so you can't do anything with that. So what's going to happen here is whatever's left over is your answer. So it's 2x squared times 1 plus 2x, that's the numerator, divided by 2x minus 5 times x plus 2 times x plus 2. And that is it for the answer. It doesn't look very simplified, but that's all you can do with that. Okay, so that is your solution. So go ahead and turn this over. We're going to stop the video now at part 1, and we'll move on to part 2.